All right. Hello, everybody. How are we doing today? It's the first stream in about a month. And it's the first stream in a while because I've been busy once again making a Horizon Worlds world. But now that that's over, we have some solid, explicitly work on the engine time. Let me center this a little bit more. Ah, that's good enough. Actually, wait a second. I have the ability to zoom optically. There we go. It's a little bit better than being like as far away as it has been. Okay. Yeah. So in that month, I have not fully figured out how we are going to structure objects in the game engine, or what paradigm are we using for objects in the engine. And yeah. And that's what we need to figure out before we move forward. There is certain things that I know still need to be done on the scripting language. Like, I still need a good way to do function pointers. I still need a way to... Well, I need a way to define and call functions. I need, like, a lot of different things to be defined in the runtime itself still. Like, there's still a fair amount of work to be done there. We have a language that works, but the language doesn't work enough yet. And before moving any further on with that, what I really wanted to do is decide how the engine will be interacting with the scripting language. What is our update loop going to look like? What are all these different systems that we need to design? What are they going to look like? Because that slightly changes the way that our scripting language works. One of these things is, I know that I want to have the concept of interfaces. So now these interfaces technically act a little bit like components in the aspect of, I know that I want there to be a not scene object, because Brane Engine doesn't have the concept of scenes itself. Like, we don't have that concept. But we do have the concept of there's an object in our game, and this object might be a chunk. Like, chunks will be derived from objects. Objects will have an... Actually, I'm not sure. I just realized the interfaces only really work for... Interfaces only make sense if... No, they still do make sense. Interfaces still do make sense. Or traits. Traits... What I'm calling interfaces act very similar to Rust traits, because Rust traits are they are an interface. They're... Yeah. Different form of interface. Maybe we stick with the Rustisms and call them traits. But I'd like the idea of them being an interface because they are a way to interact with the thing rather than like a trait of a type. So objects, I'm thinking it makes sense for them to expose interfaces. Now, other similar to this is similar to components in entity component systems, where you can do a for each call for all the objects that have a certain component. But in this case, it's like, does the object expose these interfaces? Similar to components, but I guess you can only have one interface of each type. So similar to components in ECS, but does not map to data, only behavior. And that's a good way to explain it. And I can't spell behavior ever, because I think it's supposed to be behavior. It is behavior. Actually, monobehaviors are spelled with UR. Yeah. This is why I can't spell behavior. U is British. Okay. I mean, that's like... Okay, so we use American color and British behavior. Because I know color is the other example of two different spellings of the word, and you use the American spelling of it. The other thing is I want objects of objects explicitly behavior of objects is explicitly defined per object, and it is opt-in for emergent systems like physics. As one example. I know that I want objects in our game to expose interfaces, be similar to components in ECS, have interfaces that are similar to components in ECS but do not map to data, only behavior. So this is like it's just a way to talk to an object. Behavior of objects should be explicitly defined per object and is opt-in for emergent systems like physics. So because we're making a user-generated content system, the paradigm that entity components have would lead to a lot of, like, even if we scoped systems, like ECS systems, to only work within specific chunks, for instance, like the objects in this chunk are only affected by the systems of that chunk and no other chunks. Like, how do you deal with objects moving from one chunk into another chunk? Those still need to be, like, separated. So that is, like, explicitly we can't use a generic ECS system for the engine. Now, another thing. Interfaces must support back support multiple request response cycles in a single frame. Got rid of the library? Not got rid, but I did move to a different room. So this one is a lot nicer. So our interfaces, we can't use a generic actor model or the way the actor models would work. This rules out frame locked responses This rules out frame cycle dependent responses. Now, what do I mean by that? What I mean by that is a good solution to a decent solution to the one of the problems I'm trying to solve of unexpected data mutation at different points in the frame. Basically like race conditions within a single frame, where I expect like object positions is a huge victim of bugs of what I'm trying to solve here. Is a lot of times you'll expect the final position of something to be available at this point in a frame, so you'll take the position of an object and then use it directly at that point in a frame, Why not prevent that by just not accepting new information after the frame is rendered? Because I want the information for this current frame that's being rendered, but I don't know when the data for an object is, or at least I don't know yet how to grab the version of data that I want within this current frame. If I just use only last frame's data, it solves all these problems, but then the data that all objects are working off of is a frame late instead of any calculations that might happen within the current frame, unless you expose specific interfaces to grab current frame data. But then you also run into issues where, like, okay, how does a object signal that the data is now ready, and yeah, how does an object signal that, like, the data that it was calculating is now ready? And also, what if we get into circular dependency situations where one object wants the data from the other object, but the other object also wants data from this object, and they're only giving you data at a certain point in the frame, but we're in this point in the frame, and they both want the data from the later part of the frame, so the frame doesn't continue. And I'm trying to figure out a way to design away the possibility of creating frame locks somehow. But the most solid ways to stop frame locks is to have conversations between objects happen over the course of multiple frames. But in a lot of cases, you want those conversations between objects where they're exchanging data to only happen in a single frame. Because they could happen in a single frame, and it would be better if they happen as a single frame, because then your game is more responsive. And maybe not even frame a single tick. Because from the beginning, I'm expecting that we're going to have... I'm going to design from the beginning to have authoritative servers. Because that's the sort of experiences that I want to enable with this engine are games. Not necessarily social experiences, but like fully built out games on the engine. Because social experiences are very easy to create within a system that like allows you to create full game experiences. So multiple request response cycles in a single tick. No, because it's not a frame, it's a tick. Like a server tick. And this rules out frame-dependent responses. Because, yeah. One of the, yeah. Let me bring out Paint, because I kind of want to describe the different paradigms that I'm talking about. One of the things that I think I do want is for us to have a tick request of objects. So like, hey, every single type of object, please go through your tick routine. And then a server tick is done when every single object has finished their tick routine. And the way that we handle stuff like events that must happen at the exact same time across all objects, things that can't happen asynchronously, basically, is so these are the events that this object can respond to. Had an interesting idea. But this tick cycle is going to be a pipeline. So it is a coroutine or asynchronous or whatever you want to call it. So if you want to do something after the physics step, you do events dot physics and then whatever like pipeline blocking, whatever my syntax for awaiting pipeline breaks is going to be, let's just say wait until physics is done. And then after physics is done, you can do after physics data. And then you can also say, like, I don't think we're going to actually have a late update system, but if we wait until after events dot late update, then we can do behavior that happens after late update. So basically, all of your different scene update things happens within the same like function or same coroutine, but instead of being in Unity where it's like a little bit vague what order things happen in, even though you have like the names of stuff, in this it's like very explicit to like, oh yeah, of course late update happens after physics because the event object I get back from, or the version of events that I get back after waiting on physics doesn't contain an ability to wait on anything after that fact. So you have an implicit order of like when the events happen instead of an implicit order that you have to go research with documentation and whatnot. Now, let's say we have two objects. And this is their update cycle. So this is 2.b, 2.a, 1.a, and I'm saying this because this tick function will be passed the object that we are updating, kind of ECS data oriented like. So tick events and then the old object, and then I think what this will return is this will return the new object. Honestly, that's how they could do pipelines, is just have them be explicit returns, just have return statements there. That could be my syntax for pipelines. A pipeline is just a list of functions. List of closures. Yeah. Then this is 1.b. So these are the new version of the objects after they've gone through the tick cycle. So after they've gone through the entirety of the tick cycle, what they if they, like, say here, request data from this object. So we check if it has an interface, we call the interface, and then eventually we're going to get a response from that interface. Or maybe we don't need a response from the interface, but I'm not worried about those cases at all, because you can fire off as many of those as you want in a frame. What I am worried about is okay, that's an interesting idea. What if I could make objects only accept data at certain times in a frame? Or not only at certain times in a frame, but what if I could make objects only accept, instead of accepting at a certain time in a frame, it's like, I need this data sometime before this time in the frame, and then after that time in the frame, I don't accept it anymore. So like a time-dependent interface. That way you could make sure that... I'm just trying to think about how to make that practical. Because it's very easy to, in type data, say what interfaces this is. But as soon as you get into time-based interfaces, then that becomes a dynamic instead of a static check against objects. Well, I guess it always has to be a dynamic object, or a dynamic check. Okay, okay. So if when we request an interface for an object, they still have an interface. Not like an object doesn't have an interface for like animation after the animation step. You can only set the values for the animator what I'm thinking about right now is dynamic checks for interfaces. So let's say in this area here is where, like, you could set animator vars. This is the time in which you could set animator variables for the current frame. And then after that point, it's future. Future animator variables. But I don't want to lock all of the animators to run at the same moment. In fact, I want to... It depends on how data or speed efficient all of that is. We're super leaning into multi-threading. After that is future animators problem. Indeed. Because like here you could get the interface for setting the current animator's frames, and after that you could set the value for the past animator's frames, and then you would get an error if you tried to set the animator vars for the current frame. But here's the thing. Now, after thinking about that, I want to have a way to ensure that my object always is able to set the animator variables of that object. But then you run into the issue of, once again, there's two types of awaitable things in this entire situation. Two different awaitable things. So there's one. There's global events, and the main global event I can think of right now, and we only care about tick events at this time because, like, tick events is when, like, data mainly changes, and there's, like, going to be on render events too, but that's mainly going to be for visual entities, like entities that implement the render interface. So we're gonna say global tick events. And one of these is update physics data. Or I'm gonna say provide. The other one is get physics. Data. And this is like, since the physics system we're going to be using, Jolt, is multi-threaded, we can run other jobs in the background while the physics system is running. And we can decide how much of the physics system we want to take up budget in a frame. And it may make sense for the physics system to be the only thing that we run for an entire frame, or for the time that we need to run the physics system. It might make sense to fully utilize every single core to run the physics system. But that's kind of like, that's a problem for when we get to it. The main thing is, like, if we don't have a very... If the physics system isn't very demanding right now, then we can provide physics data, and then when the physics system is done, we can get physics data back. And both of these are like optional to listen to. Actually, thinking about it, it makes sense to fully pause most all computation of our thread pool while physics is occurring, because physics holds up the entire tick. So we're gonna just say physics. We aren't going to overcomplicate it. Let's redesign this later if it makes sense to. So physics. Every single object that interacts with physics has a definite before physics and after physics phase. And there's some things we only want to do after physics, there's some things that we only want to do before physics. Like, we probably want to apply forces before physics. And if different entities are communicating with each other, or their update systems are communicating with each other, then we want those different update systems to be able to coordinate, sharing data with each other about those things before physics happens. And it'd be kind of useless to do that after physics happens, unless we want to apply those things on the next frame. And that is kind of like, that is one of the weird things of the physics system is I guess after the physics system is when you deal with contacts, and then you still might apply forces because of contacts. And then not apply them this current frame. Unless contacts and applying forces are different stages. They're technically different stages of the physics system. Oh, nice. Playing through it before playing through Silk Song? Or Skill Song? Silk Song. Let's see. Nice. Let's see. So global pick events. And then there's also 1-to-1 events. I'm gonna scale this down and get it out of the way so we just get mistaken for that. So we have 1-to-1 events, which are events between one entity and one entity. And this is where entity entity requests data from another entity. And then there's also entity entity sends data to another and these are our two main use case, two main timing dependent, these are our two things. We need a way to request data from other entities and to send data to other entities. And that send data, sending a message that doesn't contain any data is still technically sending data, because it's like has this event occurred or has this event not occurred, or how many of these events have been sent. That's still sending data to another entity. And we need a way to deterministically schedule these events. And also, so we don't need the way that these requests, these one-to-one events, sorry, I don't know if you can hear siblings screaming in the background. They're doing fine. we need the ways that these events interact. A way to structure the way those events interact. Within a single tick function. And because I'm going the simple route of not having like ludicrous amounts of... Since we don't have like a ton of metaprogramming in our language is a C-like, there's basically no metaprogramming aside from like a basic templating generic system of like, is this grammatically... When we fill in the wildcard types, is this grammatically coherent? Like, does this type actually have that function that we defined in the template? Error if so, no error if not. Implicit interfaces and all of that. We have no way to actually statically check the data between, or the control flow between these different events when they actually happen. So what we need to do is almost we need some way to schedule. Sorry, I know I'm repeating myself. I'm just trying to get myself to... I am poking my brain until something falls out. And the way that we could do this is, what if event sending data between entities isn't like a thing you can do whenever you want? What if it's a static relationship, not a dynamic one? But then you still get into the issue of, like, what if there's an emergent system like physics, and you need to be able to send events to any entity within that, or any entity with an interface in that area. Entity requests data from another entity. Like I wrote mother entity. No, this is another entity. And this is similar to how entity component systems schedule this is similar to how entity component systems schedule jobs, but the thing is, we want, at least I think we want, our entities to be opaque. Like, you don't know what operations are happening in there outside of the interfaces. And without a way to, like, statically, before all these things are run, unless we have a scheduling phase and an actual running phase, which is a dynamic That would be a dynamic version of what I'm trying to figure out a way to statically do right now. Though I guess it isn't static, it's all dynamic because dynamically loaded, but it's kind of like, is it done every frame or like just on load? Bevy system scheduling. And in an entity component system, you have a god's eye view. You can see every system that will ever exist in your game, and you manually schedule them so that they don't step on each other's toes. If a specific system must always be run before some other systems, you can add ordering constraints explicitly. And then when you have a lot of systems that you need to configure, it can get unwieldy. Consider using system sets to organize and manage your systems. Then you can also have circular dependencies between different systems depending on them, where it's clearly impossible to resolve a situation like that. Well, they're not saying what happens if you do this, but this circular dependencies problem is the one that I'm trying to fix right now. Okay. So they're not audible. It's literally just before and after. But I don't want to do it as coarse as before and after. Before and after is very easy, but I don't trust people to do it. So I want some implicit system that's slightly more complicated but forces people to do it correctly, so you don't have off by one errors, especially since this user-generated content system and people aren't guaranteed to use things correctly. Prioritization, how? That's the thing. What I'm dealing with is I don't know what data entities are going to try to send to and from each other, and how they're awaiting global events. I don't know that currently, and I'm trying to figure out a way to know that. Setting something higher or lower priority than another thing. This is a user-generated content engine. You don't know everything that's going to exist in the scene with you. You can't set priority, the correct priority for objects that you don't know if they exist. So priority is just straight up not a good system, even in existing game engines, because it's extremely coarse. Especially since we're doing multi-threading. So always run this system before this system doesn't work because you don't know if these systems are actually dependent on each other, and you just get back to single-threaded execution again. So yeah, I do not like priority. as a way of scheduling systems. I want explicit dependencies, and the explicit dependencies should be dynamic. And this might be an unsolvable problem, to be honest. And that's why it's been like a month of me just looking at this issue right here. This is the issue that I've been trying to figure out for a month, and I have no clue how to figure it out. And the problem I'm trying to solve is, oh no, did I grab the position before or after the animation system? Because the animation system is not globally scheduled, and I don't want it to be globally scheduled. And the solution, maybe, is just to have like a ton of globally listenable events. And custom systems can also define their own globally listenable events. And then if you want to explicitly interact with this custom system, you need to listen to its global events. But now, we're locking a multi-threaded system to a series of multi-threaded events. Probably coming up on the kind of problem where if it was solved, there wouldn't be so many issues that are still come across with class inheritance. I don't know what class inheritance has to do with this. How does procedural generation solve this? I'm not sure what type of procedural generation you're talking about. This wouldn't be a problem with procedural generation because they have a defined interface of where you put custom structures, and then you don't have to worry about scheduling it. Because structures aren't changing at runtime per frame. Yeah, I'm not talking about procedural world generation here, I'm talking about per frame timing of passing all data between entities. Whenever an entity communicates with another entity to grab its position or whatever, I want to be very clear about what version of its position it's grabbing. Is it grabbing the last frame position of the entity? Is it grabbing the post-animation frame version of its position? Is it grabbing the Brane? Work with me here. Yeah, just like which version of the data is it grabbing? Something generated before another, getting part of it deleted. That's a problem with how they're positioning structures, less so than an actual timing event. I don't think the issue there with procedural generation would be timing, because you don't have a well-defined, like, if these two structures are intersecting, how should they interact with each other? They probably shouldn't be intersecting in the first place, would be my response to that, as opposed to like they need a better way of deciding which one is generated. That's something that would probably happen on a single thread, so it's not a timing race condition as I'm talking about here. At least I think. It's more so just like that's a design problem of the actual procedural generation system specifically, not really relevant to this system. Well, that's probably what it does, is just base it off what lives first. And because that's the default option. But in this case, I'm worried about in Minecraft, if two buildings intersect with each other and overlap, it doesn't crash the entire system. In my case, if two entities are relying on data from each other, and neither one is giving each other the data they want because they're both waiting on the other entity to finish computing data, but both of them are waiting on the other entity to finish, then you run into an issue where you never get the data you want. So, and what I'm trying to figure out is a way to ahead of time verify that they'll always be valid. That way we don't run into issues where, okay, well, one of the things I could do to stop the entire frame from halting infinitely is like check if one entity is awaiting on another entity, and if they're both awaiting on each other, throw an error. One of the second entity to start waiting crashes. But then you're crashing entities, and that's going to be that's not going to be a fun bug to debug, because you're like, my entity's crashing. Why is my entity tick function crashing? And now I need to figure out a way to make sure that my entity, like, I need to independently solve the issue that I'm trying to solve right here for that specific use case, instead of just solving it for the whole system as a whole. And the only way to do that is to somehow design interfaces in such a way that you can't request data somehow make it so you can't request data I'm just gonna write out like a couple of events on here between these two systems. Oh, come on. One of these was supposed to be erase. I thought it was like control or something. We have these two frame loops happening here. And let's say right here, before continuing on with my frame loop. Okay. The scenario I'm trying to describe is, let's say this is the physics. This is a global time step. So this is unnegotiable. And then this entity wants this data here. This will stall the frame forever because this data is never available until after physics. But this handle right here, this entity here, wants that data that's only available after physics, but later in its frame, it wants physics. So, what might happen here is that either this will stall the frame forever, or this entity will just be paused forever. This entity here will continue on with its day, not paused by this entity. The physics time step will execute, and then data will be passed to this entity here. When this has completed. And I don't want... Yeah. And, well, actually, yeah, this would... Three philosophers problem. Let me look this up. How do you spell philosopher? Defining philosophers' problems, computer science. Actually, let's just do Wikipedia. Defining philosophers' problem was an example problem often used in concurrent algorithm design to illustrate synchronization issues and techniques for resolving them. 5 philosophers dine together at the same table. Each philosopher has their own plate at the table. There's a fork between each plate. The dish is served as a kind of spaghetti, which has to be eaten with forks. Each philosopher can only alternately think and eat. Moreover, a philosopher can only eat their spaghetti if they have both a left and right fork for some reason. Thus, 2 forks will only be available when their 2 nearest neighbors are thinking, not eating. And I can see where this is going. There's an odd number of them, so there will always be a mismatch. Well, after a individual philosopher finishes eating, they will put down both forks. The problem is how to design a regimen such that any philosopher will not starve. Each can forever continue to alternate between eating and thinking, assuming that no philosopher can know when others may want to eat or think. Okay, so this also has like we don't know how to schedule this. Yes. that is coming in handy, because, like, I can know how to code, but I often don't know these things exist. Because this is the exact problem I'm trying to solve right now. Challenges of avoiding deadlock, a system state in which no progress is possible. Yep, to see that a proper solution to the problem is not obvious, consider a proposal in which each philosopher is instructed to behave as follows. Think unless the left fork is available, and then pick it up. Think unless the right fork is available, then when it is, pick it up. Both forks are held and eat for a fixed amount of time. Put the left fork down, put the right fork down, and repeat from the beginning. When these situations arise, where each philosopher holds their fork to their left in that situation, they will all be stuck forever waiting for the other fork to be available. It is deadlock. You have like your mutex lock situation. And that's a situation where you need at some point for them to put the left fork down. When the right fork is not available for a long enough period of time, wait and then attempt the system again. And that's how I was planning. That was basically how I was planning to solve the problem of deadlocks in Brane Engine. Was like, if you can't get all of your mutex locks out once, release mutex locks, let other systems continue, and eventually you get to a point where you'll have all of your resources available. Someone has to come across it before. Yeah, this is in no way a unique error. It's just me sitting here wanting to... I want to design a system where there's no errors. And no. I want to design a system where I can statically check for errors before they arise. Like, I want there to be a... When I try to compile the code, it tells me that you're going to get a deadlock out of this system. That's what I want. Or when the application starts. Like, but I want the engine to tell me in the build phase if I'm going to get a deadlock. That's my problem. And I guess the bigger issue with this is that I can never statically guarantee the result of dynamic. I can detect deadlocks when they happen. That's easy enough. I can detect static deadlocks when they happen, but I can never... If we're able to, at any moment, change the entities that are getting waited on, I just can't know. Well, what if you forced unresolved values to use the default value, then mark the variable for a second call, or just force the variables to use the relative default? I hate solutions like that. Like, I hate when things fail silently. That would be a silent failure. I would prefer it throw an error and completely stop working, rather than attempting to continue on. But the problem with that is that I run into situations where now every single request between objects can be failable. Like, every single one of them needs to have a result that you need to unwrap before you're able to access whatever data. So every single object will need to be able to account for, like, what if it didn't execute? Maybe it does freeze until forcefully resolved. It will always freeze forever. This is a while true loop situation. Like, either an error occurs or it stays frozen forever. In most cases, I'm fine with it freezing for a long period of time and then getting resolved and causing the frame to be longer. Like, frame compute to be longer is fine. Inefficient sorting is fine. Errorful sorting is not fine. Errorful scheduling. In this situation, this freezes because in this situation, the physics time step, this physics event, is required, or the way that I have this system kind of working at the moment, and it's really, physics is the only global event in this case, but we can think of physics as let's think of physics as another entity, so that this becomes a more generic issue. So physics is another actor in this system, we'll call it. Because this is loosely similar to the actor model. So I have physics, and physics, before physics can run, it requires this data. It requests from every entity that every entity doing physics, please give me your data so I can run a physics simulation. And then after the physics simulation is completed, we send the data back to the entities, and the entities can await that updated data about themselves, like their position. Collision, false, transparency 90, debug display, error link. You're saying it forcefully halts until a programmer is forced to resolve it? That doesn't work, because this is a user-generated content system in which you're in production interacting with objects that you have no control over, that are opaque. They're a black box with interfaces exposed, and it doesn't, any solution that would work fine in a dev environment doesn't work, because this is going to be in production interacting with objects that you didn't have the chance to test. Like, testing is not an option, because it's an untestable, there are untestable scenarios, so it needs to work in all scenarios, or it will have errors. So now redrawing this entity wants data from that entity, and this entity wants data from that entity. So this is our deadlock situation from pure entities. So this is no global, let's say there's no global events here. This is only through one-to-one events. Purely through one-to-one events. Request of data, a request of a giving of data. Actually, no, this is all data requests. But some of them, there's a data request and then data give. If you're giving data, it's telling another object to request data from you, if that makes sense. But essentially the link is the same, like functionally it looks the same. The dependency graph looks the same. So you don't want quiet errors, but you also want no errors. I want errors in my development environment. I don't want errors when my code is running. So I want errors when I press compile. I don't want any errors at all in the production environment. And the solution to all of this is to care less. That's the easy solution. Off by 1, frame errors go burr. But I at least want some way to enforce the ability to reduce frame data being off by 1. Stale data might be a better way to solve this. How do I stop frame locks without data becoming incredibly stale? If I remember correctly, it was shown in class the way to solve the 3 philosophers problem involved a lot of mood text locks forcing the order that we want it to be happening in. Yes. It's the 3 philosophers problem, or the 5 philosophers problem, is a solvable problem. I want to be able to detect unsolvable problems, and then, because this is an unsolvable problem, I need to detect what problems are solvable and what aren't solvable, because if a problem is unsolvable, then it's unsolvable. I don't have a way to solve this. What I want to figure out is a way to detect ahead of time when this is going to happen, and then notify a programmer so they can change their code so it doesn't happen. So explicitly, I don't want this code to work. This situation here, I'm not trying to solve it so it will work. I'm trying to solve this so in my development environment, I'm notified that this problem could occur, and then be told how to, or not be told how to fix it, but just have a reasonable path to fixing it. And that might just be like, this object instead requests data from this object after this point. I now change my code, it's now a solvable problem. So I don't care. I realize that I don't care about solving the philosopher's problem. I care about, let's say we have this thing, with these instructions the situation may arise where each philosopher holds the fork to their left. In that situation they will all be stuck forever, waiting for the other fork to be available. It's a deadlock. So I want a way to scan the list of instructions and go, this will cause a deadlock. And then notify the programmer, or let the programmer write code in such a way that they can be aware of when that deadlock will occur. Without looking, copying a list that displays resolve values, conveys them to the previous loop and throwing a warning error? What about... that sounds like something you do at runtime. Based on whether each loop was the exact same. No, I'll know when it doesn't work, because the frame won't complete. It's a deadlock. No further execution occurs, and my solution for that is, after some amount of milliseconds, I'm just going to kill code. If code takes too long to execute, I kill it. as a way to like tell programmers, hey, make your code faster. Otherwise, I will be killing it in the development environment if it's not executing fast enough. Write your code in such a way that it can be scheduled around, or it won't be run. But see, this is a solvable problem in a game engine where I have access to the instructions. So the problem here is I don't have access to the instructions. Yeah. Problem is I don't have access to the instructions. And also, there's also the issue of, like, but yeah, I can't profile the time between two frames because this is an issue of frames not completing. Oh, you're talking about, like, if it takes too long to, So, I'm not talking about, like, the frame as, well, what I'm talking about is within a single frame. If you do have beefy operations, there will be a way to time slice it across multiple frames. And I only kill specific slices if they take too long. I don't kill the entire system. Well, I guess killing a slice would kill the entire system, but as long as, like, you have a long running for loop and there's a way to pause that for loop, then it's fine. It won't get killed. My problem is if you make the player drop below an acceptable frame rate, that's unacceptable. So that's when, like, stuff starts getting killed off. No 20 FPS. Must continue updating. Must continue running. Maybe that could, if that's, like, too, if that's too aggressive, then it could be a setting that players can set. But yeah, I just really want to incentivize people writing code in such a way that it does not stall frames ever. No way to recreate the killed frame or create it close enough. It doesn't kill the entire frame, it just kills the system that was holding up the frame. And none of those are going to be all of those are going to be objects, one of these like tick updates, rather than a like core system to the engine. So like one object in the world will stop working and everybody will stop lagging. But yeah, that's not the problem I'm trying to solve right now. Especially since that's an opinion I have rather than a problem that needs to be solved. Like if everybody's game is crashing because of my time limits, I can just remove the time limits, and then we're good. And then everybody's under 20 FPS, and it's fine. Because now the game's run at all. I don't think that's going to be the case, but that's not the problem I'm trying to solve right now. And the problem I'm trying to solve right now is what paradigm do I use for scheduling when things happen when, and making sure that like people are aware of what data is happening. And maybe this the solution to this is education of game developers. Like, hey, write your systems, listen to these certain events, don't write them these certain ways, instead of having the compiler itself babysit everybody. It's the kind of like, don't use Rust, get good and use C. Those are the two like paradigms that are fighting in my head right now. Do I just let stuff break and tell people to get good? Or do I have the compiler itself say, bro, you're not good, I'm not shipping this? Your documentation is very important, and I'm of the opinion that code should be self-documenting, and not just self-documenting, it should be self-enforcing, so it doesn't work, it doesn't even compile until you use it correctly. So, in a sense, the documentation is, if it works, it works. If it compiles, it works. Once there's a thought experiment like this, there tends to be people going, boy, what if it's this way instead, to death? Yes, and that's the problem, is I've been stuck on this issue for a month. And I don't have a satisfactory answer currently. I can move on as soon as I get a satisfactory answer. But none of them, I don't like any of them enough yet. And it's probably something like, there's interfaces, and when there's a deadlock on an entity, you just, yeah, when one entity requests data from another entity, then you just throw an error in that system and it crashes at runtime. That has the issue of, yeah, that will cause some systems to break at runtime unless they handle the result properly. If they handle the result properly, they will be fine. The answer's probably something like, and that's why if you solve this, you get a Turing Award. That would be nice, wouldn't it? Lockless multi-threading, or no, not even lockless multi-threading, but I guess this is kind of lockless multi-threading in the sense that it's compile time verified scheduling is what I'm trying to go for. Yeah. I guess I have to let it err